What if someone asks you what your speed was when you took just a stroll in the park? And let's say your distance starting from 0, 0 would be at 1 meter after 1 minute, 4 meters after 2 minutes, and then 9 meters after 3 minutes. So I chose these points purposely just to make things a little bit simpler. So your coordinates are 0, 0, 1, 1, 2, 4, and 3, 9. And the y-axis here represents your distance in meters. And then the x-axis represents, let's say, seconds. So if someone were to ask you what your speed was throughout this whole stroll for 3 seconds, you can definitely find the speed. You just take the original point, 0, 0, and then take the point 3, 9, the final destination, and then you find the slope of the line that connects between 0, 0 and 3, 9. That slope will give you your average speed from 0 to 3 seconds. So let's find it. So the slope is going to be y2 minus y1 over x2 minus x1, which is 9 minus 0 over 3 minus 0, which is 9 over 3, which is 3. So that is 3 meters per second. And it makes sense. You walked 9 meters in 3 seconds. So that means your average speed from 0 to 3 seconds would be 3 meters per second. And it works out perfectly. So this line that connects from 0, 0 to 3, 9 is also known as a secant. And the secant, the slope of it, gives you the average speed in this particular instance because we're dealing with distance and time. Now what if someone asks you what your speed was at, say, 1 moment in time? Let's say at 1 second. How would you tell them what your speed is? Maybe we can apply the same strategy. Okay, let's try that. So let's say someone asks you what your speed was at exactly 2 seconds during your stroll. So then my coordinate at 2 seconds is 2, 4. And then just like before, we can use the slope formula. M equals y2 minus y1 over x2 minus x1 to find our speed. We have x1 and y1, which is 2 and 4. But what's the other point that we use? Can we use 3, 9? But if we use 3, 9, that would be the speed from 2 to 3 seconds. Can we use this point 0, 0? But then that would be the speed from 0 seconds to 2 seconds. But then what they wanted was the speed at 2 seconds. And how do you find that? That's exactly what a derivative is for. Because using a derivative, you will get a formula that tells you the slope at any point. The slope of a line at 2 seconds. So what do we mean by slope of a line? Of a curve, you would need to draw a line that just touches 2 and is linear. And that is known as a tangent. And this tangent slope will give you the speed at 2 seconds. So then you can graph as accurately as possible, draw the tangent, and then get the slope of the tangent. But you can also find the derivative of this particular function and get the slope. So I purposely chose these points because it makes making a function for this, an equation for this curve, easy. So the curve equation here is actually y equals x squared, as you might have guessed, where we have the restriction where x has to be greater than or equal to 0 and x is smaller or equal to 3. So if we have the equation y equals x squared, the derivative for this, which can be covered in another video, is 2x. Now this equation 2x, which is the derivative, gives you all the slopes of tangents at any point on this curve. It's so powerful. So let's say we want to answer that question where your friend asks, or someone asks you, what is the speed at which you were traveling at exactly 2 seconds? All you have to do is sub in 2, the x value 2, into the derivative, which was 2x. So then if you do that, you get 2 times 2, which is 4. So the slope of the tangent at 2 seconds is 4 meters per second. So you were traveling at 4 meters per second at that point in time. It's so interesting because look, our average speed was 3 meters per second. So if you had to guess without knowing derivatives or tangents or finding the speed at any particular instance in time, you would have probably answered 3 meters per second. You would have probably never have guessed that at that moment in time, your speed was 4 meters per second at 2 seconds. And as of course, and this is assuming that you are traveling in this x squared type distance time function. So that basically describes what a derivative is. And in the other videos, we'll go through how we can find the derivative of particular functions. If you have any other concepts that you would like me to cover, please leave that in the comments.